So when you've defined a fluid in Whitson Plus in the BOT module, you actually get the initial reservoir fluid properties. So you get the oil saturation, which is in this case we're looking at a undersaturated oil, the associated formation volume factor, solution GOR, viscosity, etc. In this case, we're looking at a reservoir fluid that's classified to be a volatile oil, and we can get a little bit more information about the fluid type by looking at the phase envelope as well. We see that we're to the left of the critical point, and we're then dealing with the bubble point if we go, or if the pressure is reduced and we go across the saturation pressure. So we know for sure that this is a reservoir oil. What we know very well is for instance, reserves calculations, it's very simple to deal with reserves calculations for an oil because it's just the hydrocarbon pore volume divided by the formation volume factor for the oil, or the oil formation volume factor. A very, very simple formula. So then maybe some of you wonder, why do we actually then also report this total formation volume factor BT? Well, the reason for that is that in an ideal world, we would like to use the exact same super simple formula no matter what type of fluid system we're dealing with. So if we're dealing with a gas condensate, or if we're dealing with even a two-phase saturated system. And in the manual in Whitson Plus, you can actually see the definition of the total formation volume factor and the total GOR. And that's just to provide everybody with a very, very simple tool where we can then apply the same formula no matter what fluid system we're dealing with. So we are simplifying our lives. So no matter if you're dealing with a wet gas, gas condensates, near critical fluids, two-phase saturated system, or an oil, still always hydrocarbon pore volume divided by formation volume factor, the total formation volume factor, and then you just multiply this with the total GOR, and I'll come back to that. And to really emphasize the power of this, it makes much more sense to look at a gas condensate. So here, this is a different case, a different fluid. We see here that we're dealing with a gas condensate. If the pressure is reduced, we're hitting a dew point, which is the definition of a gas condensate at reservoir conditions. And then we can see here we have the formation volume factor, or the gas expansion factor. We have the solution CGR, the viscosity, etc. And again, just to re-emphasize, this is the gas condensate with a dew point of around 4,500 psia. But again, we have the total formation volume factor and the total GOR. The total formation volume factor is simply just the BGD divided by this RV term right here. And that gives us the same units as the oil formation volume factor, which is reservoir barrels per stock tank barrels at surface. This is typically a number higher than 4 for gas condensates, and the more near critical you get, the lower it becomes, and the leaner you get, the higher it becomes. But in the exact same way, you can then take this, even though it's a gas condensate, take the hydrocarbon pore volume, divide by the BT, and then that's to get the original oil in place. And to get the original gas in place, you simply take the calculated oil in place and multiply with this RT number right here. Very, very simple. And even better is it if we then, in this case, just for example purposes, we reduce the pressure to be within the two-phase envelope. So we're then dealing with a two-phase saturated system. Now we see that we have an initial oil saturation and an initial gas saturation. Here we can also see that we're inside of the two-phase envelope in this particular scenario. And we have a total formation volume factor for oil that we can still apply. We just need to know the hydrocarbon pore volume. We then divide that by the BT, which is then automatically done for us. And then we multiply this number with the RT to then get the gas in place. Okay? So hopefully you learned something new in this episode, and really the power of using these total formation volume factors for oil and gas, which are they have been documented in the literature for a very, very, very long time, as for instance observed in the phase behavior monograph.